We are back, ladies and gentlemen. It is Thursday, February 21st, I think it might be. Mr. Eicher here, still in New York City, if everything goes as planned. And here we are. We're talking about our last significance test for this chapter. We've done a test for a difference of proportions. Now we're doing a test for a difference of means. So I wanted to start by reviewing some test statistics. You'll have 4 on this page for 2 one-sample and then 2 two-sample tests. And then we'll have 1 formula in the next chapter and 1 formula after that. So you have 6 total test statistics that you'll be required to know. If you hear little crunching sounds in the background, that's my puppy Ebby enjoying a bone. She likes to learn stats, so she's up here with me in our condo taking notes as she chews her bone. But let's begin. So my goal today, we'll go over some of the formulas, and then I'll show you, like yesterday's lesson, I'll show you some calculator shortcuts. So, let's see what we have here. We have numero uno, any test statistic. Any test statistic, the general formula is follows. Any test statistic equals, it is a z-score. We have our statistic minus the null parameter, the null value, maybe I'll call it, null value. So what this is telling us is we want to know the distance that the statistic is from the null. How far away is what we observed from what we'd expect. So we are then going to divide by the standard deviation of the statistic. And those formulas, or at least some of them, those formulas we learned in Chapter 7 when we talked about sampling distributions. So that's the general formula. That general formula is pretty helpful. It's actually provided, this guy right here is provided on the formula sheet on the AP exam. And occasionally on investigative tasks, the exam writers will have you use this general test statistic formula, but in a new context. So it is a pretty helpful general formula. So that's why I included here. Why don't you see if you can write the one-sample z-test statistic and the one-sample t-test statistic that we talked about in Chapter 9. So pause this video and see if you could write those. Here we are, the one-sample z-test. We do have a z-test statistic. We have our statistic minus our null value over the standard deviation of the statistic. And then for a one-sample t-test, we have how far our sample mean is from our expected null mean. And then that's divided by our standard error formula. This is standard error of x bar. Standard error of x bar. So last week when I was around with you, we learned about the two-sample z-test for a difference in proportions. It's going to look kind of like this one. It's part of the reason I'm having you do these formulas all on one page so you could see how they relate to each other. But this one, so why don't you pause this video and see if you can write the two-sample version of that. Alright, so we have the two-sample z-test for difference in proportions. Our statistic right here, statistic is the difference in sample proportions. Our null value is often 0, so we just put a 0 there. Technically the full formula would be whatever the difference in P1 minus P2 is from our null hypothesis, but typically it's 0, so we just have a 0 there. And then the tricky part is the denominator. Since we're assuming that the two population proportions are equal, maybe I'll just hijack this guy right here. Since this is our null hypothesis, that both proportions are equal, population proportions are equal, then we can combine our two sample proportions into one combined proportion. It might be good to include how you calculate this p hat c. There's two ways to think of it. You could take your successes in your first plus your successes in your second, and then you're dividing it by the sum of the two samples, like that. Some students like to write it this way, though. If you're given proportions, it's the sample size of the first times the proportion of successes in the first plus the sample size in the second times the proportion of successes in the second. It's a mouthful. Divided by n1 plus n2. So either one of those is how you calculate p hat c. Those are also used in conditions when you check conditions for a two-sample z-test. Wow, that is a big formula. That was the type of formula that it would be very nice to use a calculator shortcut on, especially because students typically forget these p hat c's when they're doing that formula. But our new material today is a new test statistics, kind of related to yesterday's lesson about a two-sample t-interval. So let's check that out. Thinking about that, we would have, do it in blue. We have our t-test statistic. We want to know how far our statistic is away from our expected null value. Our statistic for this type of test, if we're wanting to learn about the difference in population means, our statistic would be x bar 1 minus x bar 2. That's our statistic. I'll put in parentheses just so you can see that those are related to each other. That's the statistic. And then minus the null hypothesis value. And since the null is often that the difference in the population means is 0, we just include a 0 there. And then lastly, the denominator is one big square root, kind of like what we did yesterday. And we have a sum here. So we have the first sample standard deviation over the first sample size. And we have to square that sample standard deviation. So there's a lot of superscripts and subscripts here. And then we have the second sample standard deviation squared, so it's a variance now, and then over n from the second group. This is based or derived from the Pythagorean theorem of statistics. And you can see yesterday's lesson for a little bit of a proof of where this formula comes from. And I should mention while we're here, since we don't know, typically we would use sigma here and a sigma here. But since we don't know the population standard deviation sigma, we don't use those. And we use S to estimate it. And because we're estimating the population standard deviation, that is why we use a t-distribution to calculate p-values. So let us end that. The section I'd like to talk about today is how to perform these two tests. Oh, I get to use my circle option. See if I could do it. Bam! How do we perform those two tests with the calculator? So let's turn the page and see how. I talked in yesterday's lesson about the benefits and the drawbacks. The biggest benefit for me is that it's faster. It might even be more accurate, faster and accurate, than having to type all the pluses and minuses and squaring things and stuff like that. There are two drawbacks that I mentioned yesterday. Number one, if you're just going to label two-sample t-test on your paper without writing the formula, I think one of the biggest drawbacks is just like you forget the formula. So IDK again. The other drawback is there's no partial credit. If you just write, hey, I'm going to use a 2-prop z-test, here's the answer. If you get the answer wrong, because like you typed one number wrong, then the AP reader has no clue what happened, so you don't get any partial credit. Whereas if you use the formula, and you use the formula wrong, but at least you're showing the formula and we can kind of identify what you got wrong about the formula, then you could at least get partial credit. So it's really up to you which approach that you'd like to take. But I would recommend, honestly, I would recommend the faster, more accurate approach with a nice pretty check mark to continue working with the formulas on your homework. Practice those so you don't forget those. Okay, so let's check out the two-sample t-test. If you have your calculators out, we're going to be testing an alternative hypothesis that two means are not equal to each other, so there's a difference between these two population means. The null hypothesis would be, not that it matters here, but the null hypothesis would be that the two population means are equal to each other. Another way that we could write that null hypothesis is that the difference equals 0. If they're the same, then when you subtract them, you would get 0. Okay, so again, we're going to go to Stat, and then scroll over to Tests. So Stat, scroll over to Tests, and it is number 4. This one is number 4. Let me erase a little bit of this. Number 4 on the TI. Be careful not to pick number 3, which is two-samp Z test. We never use, see that highlighting down there? We never use a two-samp Z test because that will be asking for the population standard deviation, which we often don't know. Okay, so this is going to be really similar to what we did yesterday. We need to see, do we have stats given to us or do we have data provided? And we don't have data, we just have the summary statistics. So we'll pick stats. That's very common on the AP exam. They don't want you typing in data very often because if you type one number wrong, then it's all wrong. So they'll often give you summary stats. So X1 would be the first sample mean, so that would be this group A. So we'll put a 10. The standard deviation is a 3.5. The sample size is 20. The second mean is 15. And the standard deviation is 2.5. And finally, the sample size is 25. Next, it asks us, mu colon, which of these options, not equal to mu2, or less than mu2, or greater than mu2? Well, our hypothesis here is that it's a not equal to, so we would select this option. So pick that and hit enter. You could scroll left and right to pick whichever sign that you want. And then we scroll down, so select not equal to, we scroll down, we never pool, ever pool. Again, pooling is about should we assume the population variances are equal, and I have no clue if they're equal. So no, we won't pool together our sample standard deviations. So that's just a no. Or like it says right here, we never pool. Stay out of the pool. These crazy kids nowadays jumping in my pool. Stay out of the pool. So we hit calculate, and we get this information. Maybe I'll put it over here. We get, oh, that's kind of inconvenient, isn't it? We get this information. We get t equals negative 5.38. That is our test statistic, test stat. That is what we would calculate if we did the whole x bar 1 minus x bar 2 divided by the square root of that massive thing we had on the previous page. That's the answer we would get. And the p-value that we would get is 5.795. Definitely, please, people, don't leave your answer like that. This is a probability. This is times 10, see the little e at the end there, times 10 to the negative 6th, which we'll call that roughly 0. And you should also include the degrees of freedom 33.29, round that a little bit. If you scroll down, you can see the parameters that you inputted. It's always good to kind of double check that you didn't type a number wrong. And those look pretty familiar, I think, so we'll leave it like that. So what this test statistic is showing us is, for a roughly normal curve, it's actually a t-distribution, but the shape is roughly normal. We have a test statistic of -5. That's going to be like way out here, -5, and that area. But it's a two-sided, so that would be a +5 on the other side. So we have this area, this one plus this one, is our p-value, which is very small. 5 standard deviations away is very small. So that's the result that you get from your calculator. So we would call this, we just did a 2-samp t-test, and then we recorded what the calculator gave to us. That is faster and safer than including the formula, which I will erase. But again, I would recommend, if you want to do a superior job on the AP exam, to be working with the formula. And do you know, for instance, what the denominator looks like? That it's s1 squared over n1 plus s2 squared over n2. Do you know that? Would you be prepared for a multiple choice question that gives you answer options that look like that? Okay, so that's the 2-sample t-test. You'll be using that on your lesson today, but I wanted to show you how to do the other test as well. So let me go back over here. So we talked about the 2-prop z-test over here on the right. We talked about that last week. I'd like to just walk through what it would look like to do the calculator shortcut. So if you go to Stat again and over to Tests, we're going to look for 2-prop z test. Not 2-prop z int, but 2-prop z test. That was number 6 on my calculator. So if we select that, we have x1 is being asked for, n1, x2, n2, and then the direction. The direction is this greater than. So for x1, we can type in these quantities. We can do n times p to find that x. So we have 70 times 0.41, and I got 28.7. Does anyone remember what we said yesterday about using that 28.7? Do you know? Are you saying it right now and I'm just not listening? What do we do? That 28.7, well, go ahead, try. Let's just try to leave that as 28.7. Let's just try 60 times. The next one I got 22.8. Let's just leave it and see what happens. And then 60 is the sample size for the number 2. It is a greater than, so sometimes students get confused about what sign to choose, so let me write out the options here. This is a greater than sign. It could have looked like this when you subtract greater than 0. But still, here and here, these are all this sign, greater than. So you should choose that third one. And let's hit calculate and see what the calculator does. It says domain error. What happened? You don't want that to happen on the AP exam. So it's important that you know how to debug your computer so you can erase the domain error. So this 28.7 we should have said was 29, and this 22.8 we should have said was 23, rounded to the nearest whole number, as you can see right here on my notes, on your notes. When using 2-prop z-tests, expected counts, the x, must be rounded. I guess I shouldn't call them expected counts. I should call them observed counts x, so I'm going to change that on your class notes so it says observed. But frankly, no decimals when you're typing in the calculator. Okay, so quit. Let's go back to stat. Go back to the 2-prop z-test. I need to change that to 29. Change the other one to a 23. This is a greater than. Calculate. And we get z equals 0.359. And the p-value is right below that. It equals 0.359. Wow, that's pretty cool. So the z-score, here's 0, here's the 0.359. That number, 0.359, led to a z-score that's the same. That's pretty cool. I have to share that with one of my buddies or something, one of my AP Stats buddies. Other numbers that you see at the bottom, you're given a p-hat 1. I'll just keep writing right here. You're given a p-hat 1. That's just, it should be roughly this p-hat. And then we are given a p-hat 2, and that should be roughly this p-hat. And then the most interesting one would be just the one that says p-hat. That's actually the combined p-hat c. It doesn't say c, but that's the combined proportion. That's what you would have to use to check conditions and if you wanted to write the formula. So it's kind of nice the calculator provides that for you. Okay, so that's how you use, oh, by the way, I mean, with these kind of numbers here, you will not be rejecting the null hypothesis. We would definitely chalk that up to chance, though that could be a type 2 error, but maybe another day. Okay, so that's what I wanted to talk about in this video. What I would like you to do with the rest of class time is some Khan Academy practice. You have several, but whatever you don't finish, your homework tonight is to finish them. So the first video, you'll be learning about hypotheses for a 2-sample t-test. 4-minute, not too bad. And then, very important, the example of hypotheses for paired t-tests and 2-sample t-tests. It's a very important distinction, so that's a very important video. And then this exercise will cover both of those videos, writing hypotheses to test a difference of means. And then you have one more video to watch, 6 minutes, and then you'll have 2 exercises, the test statistic and the p-value. With the p-value, you can use table B, or you can use t-CDF, not normal CDF, but t-CDF to calculate the p-value. And the test statistic would be that long formula, but you can definitely use the calculator shortcut in addition to the formula. And then I see one of these exercises got bumped. There we go. And then lastly, there's 2 more videos. You have concluding a test using a p-value. That should be pretty review for you since we've been concluding tests for a while now. And then also connecting, the last video connects a t-test to its corresponding confidence interval. And then this exercise of 4 questions will cover those videos. So you have several videos to 5 videos, and you have 4 exercises. But again, whatever you don't finish, you should finish for homework. And then that will be the end of this chapter of the new material that we have. So I hope you enjoyed this video, and good luck on the Khan Academy assignments.